Finding limits. There are different ways we can do it. The easiest way is just a direct substitution, something like this. So what we're interested in knowing is, as our point moves along the curve that we're drawing, as the x value is getting closer and closer to the value of, in this case, 5, what's the y value getting closer and closer to? That's basically what a limit's doing. So something like this we can do by direct substitution, and we just plug it in. 5 plus 7 is 12. We've got our answer. Some, however, don't work like that. And maybe we try this idea. Factorise and cancel. X approaches 3 of x squared minus 9 and x minus 3. Now it's not going to work. Because if we sub directly into that, I'm going to get 3 squared, which is 9, minus 9, 0, over 3 minus 3, 0. 0 over 0. That's a meaningless expression. If I factorise it, in this case, it'll cancel. And then that allows me to do a direct substitution after I cancel. So I know that this particular curve, as x approaches 3, it must be approaching 6. And now we have a special limit. What happens if we want to investigate what's happening out at the extremities? Because of course you can't substitute infinity into a function. If we want to see what is our curve doing as x is getting bigger and bigger and bigger, it starts with this idea, because we know what the hyperbola looks like. And yes, I can't substitute infinity into y equals 1 on x, but I certainly know what that curve's doing. And as x is getting bigger and bigger and bigger, that curve, the y value, is getting closer and closer and closer to 0. So we know that to be true. As x is approaching infinity, our hyperbola is approaching 0. That allows me to do something like this. X is approaching infinity. Now if I was to substitute into this right now, what's going to happen? Now infinity of course is really big. Infinity cubed, wow, really big times really big times really big, that's really, really, really big. Plus 3 times really big squared, so plus 2 really bigs, minus 1, who cares? On the bottom, I'm going to have 4 times really, really, really big, minus 1, what have I got? But if I divide everything by x cubed, I now get a situation where I'm substituting infinity into the bottom of the fraction. And our limit tells us whenever we do that, that fraction is going to approach 0. But the nice thing is, the x cubes end up becoming constant numbers. So all of those fractions become 0, and I'm just left with a quarter. And we know that this particular curve, as x is getting much bigger, we're heading towards 1/4. Now, the reason this happens, look, in a polynomial, the leading term is going to dominate the function, because that x cubed, because we're talking about such a big number, the other terms becomes insignificant, right? Because it's so big, they may as well not exist. What that therefore means is, all I really have to look for is the highest power, because everything else will go away. If I want to substitute infinity into this one, if everything else has gone away, all I'm left with is 0 over 1, which is 0. I don't physically have to go and divide everything by x cubed. We just look at the coefficient of the biggest power. Something like this, I can look at that and say, well, it's only the x to the power of 7 that's going to stay there. So I'll be left with a third. A third must be the limit. Here, again, it's the x cubed that's going to stay. I'm going to end up with 1 on 0. Well, that's undefined, and often we think of undefined as going off to infinity. So that's probably going off to infinity. Of course, the other thing you can always do with limits, if you're unsure, just plug in a big number and get a feel for what it's doing. Is it going towards a particular value? Is it going towards 0? Is it getting really big as well? And that's a way of confirming, oh yeah, that is going off to infinity, or it's going to 0, or whatever it's doing. It gives us another way then of finding horizontal asymptotes. Remember this sort of question that we did. Well, a horizontal asymptote, you recall, is that's what happens as x is approaching infinity. So essentially, if I want the horizontal asymptote, I'm saying, what's the limit as x approaches infinity of this expression? Oh well, x squared, that's what's going to be left behind. I know it's 1. So I didn't actually have to go and do the polynomial division for that one. I could look at it straight away and go, oh well, that's going to be 1. So that's the general idea of limits. In the handout there's a photocopy of the Terry Lee exercise for that one, 6.1.